This coastal conversation was intended or is intended to discuss the bloom in Lake Pontchartrain and what we've seen throughout the years. I am going to share my screen, so let me make sure it goes. Can everyone see my screen?
Yes, we can.
Okay, perfect. So welcome to Coastal Conversations. Again, this is meant to be a conversation about the algal blooms that we've observed in recent years in the lake, and I guess we'll kind of kick things off there. I'm going to walk you through a story about some of the data and observations that we've seen specifically from Lake Pontchartrain, and then Justin is going to take a deeper cut going back towards what does the safety elements mean, because there's a little bit of fuzzy math in there. So yeah, let's start with 2018. In early 2017, we had several calls from the public. Pictured to the left is a picture at Fontainebleau State Park from this year, earlier this summer in July. We also had an algal bloom that was observed at the Tchefuncte boat launch. So the picture on the right is some algae at what we call LP7. And our calls that we've received from the public have been pretty numerous. They've included help. I saw algae. Can you sample? So there's been a couple of sampling runs where we mobilized and tried to collect a very target-specific area of the lake for analyzing algae or collecting some information about a specific locale on a very specific day. We also had help. I saw algae, but I mistook it for hyacinth and giant salvinia. Certainly, and you'll see one of these pictures later on in the presentation, we did have a abundant amount of hyacinth and giant salvinia in 2019 that was blowing out from the different swamp areas as a result of some of the flow from the spillway. And it was a very common call that we did get to see these large patches of hyacinth or salvinia moving along in the lake. Of course, the big question was, is it safe for me to swim? We had a number of these questions. There was also kind of some sub-questions in this of, I have a special medical condition, and I have some concerns around asthma or inhalation. But certainly people were interested to know if the lake was considered safe to swim. Is it safe for me to eat the fish and crabs I've collected? Was extremely common as well, but those are two different exposure scenarios, and because the exposure scenario is extremely different, the way that we calculate risk is also different. And so making inferences about safety is, of course, a extremely challenging thing. And then, quite honestly, the thing that got the most attention was, what about my dog? I saw in that news article about the 3 dogs dying. That certainly seemed to get a lot of people's attention and get the news media to cycle and to report on it pretty extensively in 2019. And again, that exposure situation is entirely different because dogs lick their fur when they're in the water. It's a different exposure situation and circumstances associated with their recreational activities in the water. So let me start by saying that these have certainly been interesting times. In March of 2018 and 2019, we had spillway opening events. That was the first time in back-to-back years the spillway had ever been open. 2019 was the first time that the spillway had ever been opened consecutively and within the same year itself. And the amount of water that flows out of the spillway that loads up the ecosystem or the basin is it has a tremendous amount of phosphorus and nitrogen in it. So if you look at some of the historical openings, 2011 was a fairly large opening event in which approximately 3 volumes of lake were displaced, or if you counted up all the gallons going through the spillway, it would be approximately 3 entire volumes of lake water that moved through the estuary in that year. 2019, if you updated this particular chart, for the year 2019, that would go off the graph. It was a substantial amount of water, again, loaded with phosphorus and nitrogen. And those particular nutrients are something that is kind of the restrictor plate for these microorganisms. So we've gone out and collected data in 2008 and 2011, and for the first time we collected some HAB-specific water related to the algal bloom in 2019. I'm going to talk about, Justin is going to talk about what a HAB event is and how that's different from a regular algal event. But we're gonna talk about some of the sampling activities and what were done in the lake for 2019. So our sampling program consists of going out to 12 different sites on a weekly basis. We don't target any specific weather events or avoid any specific weather events unless it's related to safety. But in 2019, we targeted LP7, which is the Tchefuncte boat launch in the upper left-hand corner, LP8, which is Bayou Castine Pavilion, LP9, which is Fontainebleau State Park, LP10, which is North Shore Beach. And then we kind of alternated between some South Shore sites, but pretty consistently we were able to collect some data from LP3 and LP13. This sampling program is great because it's provided a lot of information historically. The data set goes back to 2001. So we've collected a lot of information related to pH, dissolved oxygen, salinity, specific conductance, turbidity, and then all the fecal indicator parameters. But for 2019, for the first time, we were able to collect samples and have them analyzed at LSU for different constituents of nitrogen, so that includes the NH4, NO2, NO3, or ammonia, nitrite, nitrate. The PO4 is phosphorus, silicates, and then also TOC and DOC are referred to as total organic carbon and dissolved organic carbon. In 2008, I want to take a little bit of a step back. There was an algal bloom event in different areas of the lake as a result of a spillway opening. The picture on the left you will observe has a dark green. That dark green is a very vibrant and frankly pretty green. And then you can see a little bit of a teal swirl in that lake water. That teal swirl is usually indicative, or that's one of the signs that represent cyanobacteria. Sometimes these algal bloom events will also co-occur with some very offensive odors. And then on the right picture, you can see Lewisburg, just west of the causeway. That is a different species of algae that was captured and photographed from aerial photography. But looking at these things, our data set and what we were able to gain inferences on were just some of those parameters that are more of the classical water quality parameters. The analyses for different HAB events for this particular bloom event was nothing more than an academic curiosity. And certainly we didn't have any commercial laboratories that were available or were appropriate as far as analyzing some of the toxins that are produced in HAB events. So HAB-specific data was relatively limited in the 2008 timeframe. In 2018, this is, again, a little bit for perspective. Lewisburg is in the top left corner of this particular picture. That is Mandeville to the left. New Orleans would be along the causeway to the south. There was a pretty extensive bloom in the northwest quadrant of the lake. That particular year, we had seen a bloom kind of show up in February. It was particularly cold in January and warm in February. We had questions as to whether or not this bloom was related to that, but certainly a very large and extensive algal event was observed in 2018. As far as monitoring activities, there was a variety of different organizations. LPPF, as we were then referred to, was certainly participating in collecting data both around the lake and in the Mississippi Sound. We also had partnerships or were sharing data collaboratively back and forth between LSU, U.S. Army Corps of Engineers, Southeast Louisiana, and some other entities. Mississippi was also collecting some information that they had occasionally shared with us as well. And most of these parameters included, of course, the water quality parameters, but there was some subsurface sampling. So Dr. Lopez and his group has done hypoxia sampling, where they are collecting dissolved oxygen values closer to the bottom, or looking at a stratification of dissolved oxygen across the entire water column. So they'll take multiple measures of dissolved oxygen through that water column. And then specifically a microcystin analysis related to a HAB event. And again, I think Justin will come back to microcystins in a discussion about what microcystins are. As far as the project timeline, what we expected to see, this is usually one of the figures that Dr. Lopez will reference after a spillway opening event. We had theories and have looked at data that has supported in the past. There is a couple-month lag between opening of the spillway and restoration of water quality. We will see in high algal bloom events a very high amount of DO that's above the norm. Above what we usually sample for. But certainly turbidity is very high, and that's the measure of cloudiness in the water. And the salinity is often very low, and that's indicative that it's under the influence of Mississippi River water. But when the spillway is open in 2018, we expected that rebound by August, and that's largely what happened. So there is EPA criteria. Again, Justin is, I think, going to come back to this, or we can dive into it. EPA has established criteria for two different compounds, microcystin and cylindrospermopsin. Specifically, we'll just be looking at some data related to microcystin tonight. In 2019, things was exceptionally crazy as far as the level of activity, the level of concern. On the left side of this picture was a warning sign that was posted for the majority of time in Bay St. Louis, Mississippi, related to algal observations along the beach and advising swimmers not to go swimming along Mississippi beaches. And then again, kind of like I hinted at a little earlier in the presentation, that is a large mat of both salvinia and hyacinth that was floating and mischaracterized by some passersby as being algae in the lake. So when we talk about HAB events, one of the really important things to kind of start off with is identifying the species that are responsible in any given bloom. I will greatly betray my North Florida accent if I try to pronounce this particular species, or excuse me, genus name. So I am just going to refer to this as Anabaena because it's much easier for me to pronounce. But you can see it has a morphology that's very circular, and then it has a pod towards the end of that particular formation. These are all unicellular. They're fairly small at 10 microns. You can see the space within it. We also had collected samples, and in addition to Anabaena, a lot of our samples contained microcystis. So these are the two species that are responsible for the production of microcystin as one of the main toxins of a HAB event. The Anabaena is pictured to the right, so you can see the structure of Anabaena, but you can see the ball of microcystis to the left. And again, these are our principal species of concern that were in the 2019 event. Shifting up gears a little bit, we tried a variety of things. Certainly, it's extremely expensive to put field samplers in the field. Whenever we get a phone call, it's even more expensive if that call winds up being a organism or plant material that is something other than cyanobacteria. So we had questions about the usefulness of some remote sensing technologies. We were able to work with Cyan, which is a partnership between NOAA and US EPA. They have an app that you can download to your phone called the Cyan app, and it helps a lot with remote assessments of different satellite images. We found that there's a delay in that particular product, and what NOAA did is they revised their satellite imagery. They have a satellite that passes over approximately once a day, and then they capture the image of the basin and then report wind speed and direction in the top right corner of this particular product. True color image is on the left-hand side, and then the algorithm output of a color inference or measurement of different cyanobacteria, the Anabaena or Microcystis, are kind of denoted in these colors to the right. And it's really interesting to look at what was out and present in the basin over the course of 2019. So you can see the spillway open on the left-hand side. That brown Mississippi mud colored plume is just that. That is Mississippi River water coming out of an open spillway. And then on the right-hand side, you can see a fairly high density of microorganisms that are reported or computed to be near Orleans East. And then there's a significant amount of material that's out in the Mississippi Sound. And then a slight amount that's out towards Fontainebleau State Park. And of course, this is a dynamic product. It's changing throughout the day, although we only have one picture at a time. So you'll be able to see the changes in this particular product as a result of some of the things that are ongoing. The white discolorations all along the land, those are clouds. And so you'll quickly see what happens with cloud material as we roll through some of these images. But June 16th, you can really see that there is a very high enumeration or computed concentration of cyanobacteria in Lake Bourne area, and again, off Fontainebleau State Park. By July 16th, you could see that the Mississippi River water has all swirled around, and the satellites were not reporting any observable cyanobacteria in the lake. And we found this incredibly interesting. Certainly Hurricane Barry was in the time span between the previous image and this image. But these microorganisms are also buoyant, and they will change their buoyancy depending upon their light needs. So they're producing their energy from the sun. And as their light exposure changes, they will move up and down in the water column. But you can see on the right image some of the limitations to the technology. If the cells are in the water column below a meter of depth, it doesn't pick it up on the satellite image. So, were these cells killed off or no longer present in the water column, or is this simply a limitation of the technology where you can't measure because they're at a much lower depth? This was certainly one of the very interesting findings over 2019. August 16th, 2019, of course, activity picks up. There's a lot less cloud cover. We certainly picked up in temperature. Speed has decreased. And as you can see, certainly, it's corroborated in the visible image. You can see a lot of cyanobacteria that are reported to be in the top meter of the water column in the lake near Mandeville and extending all the way to the South Shore. So it's a really interesting technology. This slide kind of represents some of the challenges associated with it. Top left corner is cloud cover. So, when the hurricane or tropical storm Barry came through last year, all that cloud cover obscured the image of the satellite. And again, it's only coming over once a day. So you lost an entire day as far as being able to remote sense any measurements as far as some of these things in the water column. And then you also have sun glint. So some satellites engineers tried explaining this to me, and I'm sorry, I'm a little obtuse sometimes, and that lesson didn't take. But depending upon the angle of the sun and the satellite coming overhead, sometimes your data can be rendered non-usable, as is in this particular image on the bottom left-hand corner. And it was constantly changing conditions all throughout the summer. So it's great to grab a snapshot using this information. It is certainly helpful as far as if you were able to get some of this information and then mobilize and go out and try to collect a sample. But if a front passes through and disperses some of that material, or a storm system comes, capturing a sample and confirming that particular sample was an extraordinary challenge. So I did want to discuss some of our findings. We collected samples and had them analyzed at LSU through Dr. Bargu's laboratory. She was a tremendous help last year in mobilizing rapidly, collecting these samples, and trying to see and enumerate the amount of microcystin that was in a given sample. The benchmark, as I stated earlier tonight, is 8 parts per billion, so it's a little bit above the 6, of course, on this graph. The predominant amount of our samples did not approach that value. The mean was certainly less than 0.5. And it was very interesting to see that even though we had an extraordinary mass of algae that was present in the lake, that genetic machinery, or the machinery responsible for turning on the toxin, wasn't present at the same time. So I've got a series of graphs. You know, as I mentioned, microcystin testing is expensive. It's complicated. There's no one preferred method as far as testing these compounds. So it would be great to have a surrogate parameter and to try to predict either microcystin concentration based off another measure, or to be able to get other data from the lake or at recreational spaces and be able to understand the possible risk associated with microcystin. And unfortunately, as you will see from this graph, we had a variety of water temperature measures over the course of the year, and we looked at the fit between microcystin and water temperature. And as you can see from the R² value of 0.005, that is a pretty poor predictor using water temperature for microcystin. So water temperature is not a great or usable predictor. Same thing occurs here with dissolved oxygen, although it is slightly better and only marginally. But dissolved oxygen, or measuring the concentration of oxygen dissolved in water, was problematic, at least for the samples we observed. Now, it's possible that if you have very high amounts of dissolved oxygen, so usually in the lake we don't see much beyond 8 milligrams per liter. If you have a higher reading of 10, it has also coincided with a very aggressive algae bloom. But again, dissolved oxygen did not predict very well over the summer of 2019 the concentration of microcystin. And of course, our salinity values over the last year have been extremely suppressed. What was on average around 13 parts per trillion, 13 parts per thousand in the 1990s, we've seen below 1 part per thousand in the basin as a result of closure of the Mr. Go, completion of the risk reduction hurricane system, and also the substantial amount of rainfall and the opening of the spillways throughout the years. So just to kind of wrap up my portion of the conversation, the microcystin values that we were able to collect data and have analyzed at the lab, all of those were significantly below the 8 parts per billion criteria that's established by EPA. Again, Justin will dive into that in a little bit. But we did have substantial amounts of microcystis and anabaena that were present in a lot of our samples that were too numerous to count. So maybe a little bit of a silver lining in this, that we have a substantial amount of these microorganisms that are there and present, but the toxin that is associated with some of these microorganisms was not, and that is a good thing. We certainly don't want to see the toxin present in the lake, even with these high counts of different cyanobacteria. And then we also noticed that the bloom appeared to dissipate after Hurricane Barry, but came back with a vengeance. That's possibly due to some of the limitations of the technology as far as the buoyancy of some of these cyanobacteria. It is possible that some of these cells were disrupted or deactivated or died as a result of some of these tropical events, changing in salinity values. But it's certainly something we are interested to try to capture more information on. And we certainly learned that satellite imagery is only useful in low cloud cover scenarios. So if we were to mobilize and to go try and capture some of additional samples in the future, we would certainly want to make sure that we have a period of time where there's low cloud cover, so that we can better utilize our manpower in collecting some of this data. A lot of the data and information that I presented tonight was only possible through LSU's and U.S. Army Corps of Engineers efforts and assistance, and Will Pestoff and John O'Donnell were the team members that were out there collecting samples for us. So if you see them, thank them. And with that, I'm going to pass the baton along to Justin, and we'll go from there.
All right. Can everybody hear me at least? Okay, good. Seeing nods. I'm going to go ahead and share my screen. Guessing I click present now. I'm not a Google. Okay, just making sure. Okay, can everybody see that? All right, just want to make sure. I'm very, very happy that Brady was able to give y'all lots of pictures and graphs, because I don't have any. My name is Justin Gremillion. I'm the Chief of Specialty Operations with the Louisiana Department of Health. And when you work for the state, they get funny about when you take others' images, and it would have to do lots of documenting and showing what I did. So like I said, I'm glad Brady showed a lot of that. But the other good thing is most of the items I'm going to talk about is a little bit behavioral. Talk about some of these toxins, some of these definitions, and how they kind of pertain to you and your pets and your lifestyle in and around the Lake Pontchartrain area. So I first wanted to say, there are different types of algal blooms. There is not always, we hear of the HAB, we hear of the harmful algal bloom, because that's what that news likes to push, that media button. They like to get that shock value out there. It makes a good story. But that doesn't mean it's harmful. And that's where the Pontchartrain Conservancy, Department of Health, Department of DEQ, EPA, we all come in now, and we're trying to figure out, okay, is it harmful or not? And from some of the information that Brady had just shared, it goes to show that even if it is a harmful algae species that's present, doesn't mean that toxin level is something that can be harmful. Now, again, that was one of the first times we had really done that kind of extensive sampling, and it was very reassuring to me to see that the lake was still extremely safe to swim in. Now, and I'm going to get to a little more of that later and what you should and shouldn't do, though, because it can always be made worse by your actions. Brady kept mentioning microcystins. So it's produced by that species Microcystis. That is our most common species. That is our most common toxin that we're going to see. That is one of the categories that the EPA has set that 8 microgram limit per liter on the recreational waters back in May of 2019. There's two species that produce these types of microcystins. That's Microcystis, which is where the name comes from, and then I can say the name, Anabaena like Brady can, but I'm gonna go ahead and give it a spot. It's Dolichospermum is how I would pronounce it, but I know that's not always flows off the tongue that way. I have no idea why they changed the name recently from Anabaena, but I'm sure there was a reason there. The interesting part about these toxins is once they're produced by the algae, they can still persist in the environment. So what that means is that we can have a bit of accumulation take place. So when we see these events and we go out and begin to sample, we are sampling the waters for the most part. But if these waters were to wash up on shorelines or on beaches, which is one of the programs that the Department of Health monitors, it can dry and the toxins actually can stay present. So even just not even entering the water, pets and people can still become exposed to these toxins. So it's always a good idea to avoid any discoloration, blue-green water or sand or the ground area in these algal bloom areas when they occur. Nature will take its course. They'll turn over, they'll decompose over a certain amount of time. But again, it's one of those things where just because you don't always see it in the water, you might see it on land, you think, oh, it's dry, it won't hurt me. That's not always the case, especially with this one here. Some of the effects from this microcystin toxin is it goes right to the liver and kidneys. It's not, I don't want to use the word not deadly because, but the mortality rate is much, much lower than some of these other toxins we're going to talk about. But it can, like most of these toxins, bioaccumulate in organisms. And again, we're going to talk about a little bit about that later. But basically what we're talking about is wildlife, seafood, shellfish, they consuming or getting it in their bodies, and larger animals eating them, larger fish or, animals that are in the wild, even ducks are known to eat crustaceans, and it can bioaccumulate in their systems. Another one we see, which is, again, the Anabaena, is the anatoxins. Now, we didn't get too much into this because there wasn't really threshold set with this one on the EPA yet. Like I said, they really only set the microcystins is the one we're looking for more than anything. But this one can potentially be produced in our area. The scary part about this one is a neurotoxin. So think, when you think neurotoxin, and this is how I try to get shock value of it, think like snake venom. I mean, it's the exact or similar pathways when this toxin gets into your body. It's going to affect your brain and it's going to affect your lungs. Common distress or symptoms from when you're exposed to these types of toxins are respiratory distress, paralysis, confusion, and they absolutely can end in death. Now, does that mean a healthy individual that walks out there and is exposed to some types of these toxins always going to end up in death? Absolutely not. These are extremely rare cases, but it doesn't mean that it can't happen. Another one is saxitoxins. Again, that's that Dolichospermum. Now, this one's interesting is that this toxin can actually be produced in two different areas, and it's two different organisms, or at least we see them in organisms, and depending on if they're fresh or marine. And remember, when we say marine, we mean saltwater. So, Lake Pontchartrain is, it's definitely freshwater. It gets into kind of a brackish. That saltwater is nice and dense. It likes to slip and slide underneath the nice buoyant freshwater. And then you got the actual, the Gulf of Mexico and Lake Borgne and all that, which is brackish to almost completely marine the further you go out. And the organisms that are in the marine or the salt water, these are dinoflagellates. So they're not really cyanobacteria anymore. They're another type of species. But that doesn't mean that they can't produce these same types of mechanisms and toxins. Saxitoxins, again, are a neurotoxin. And this is the one that we hear about a lot of times when we talk about the ingestion of shellfish. And it's called a paralytic shellfish toxin. Again, neurotoxin, paralysis. That's where that word paralytic comes in. And the reason for this one is when we hear about that paralytic shellfish toxin is because this is where our oyster reefs are in this brackish marine. They like that salt water. it accumulates. The organisms, the fish, can't really get away from these toxic blooms. They're just sessile creatures that are just stuck there, so that toxin can't accumulate in them. But as you can see with Brady's maps that he was showing, was that, you know, a lot of these blooms didn't quite occur over our oyster reefs, and actually that would have been a good slide to have, actually, some of the locations of our reefs. There are none in the Lake Pontchartrain area where these blooms in 2019, and even the ones that were slightly off the coast of Mississippi and exiting the Louisiana waterways, we don't have large concentrations of shellfish in those areas. For one, there's a large amount of fresh water that enters there and inhibits the growth of oysters usually. But also there's lots of pollution in those areas because people have built up in those areas. So we've pushed out our pollution line. And one of those reasons is to prevent things like this, toxins from accumulating. Similar items with the neurotoxin, you know, respiratory distress. Now, this is one that's kind of familiar to the marine environment. Again, there's a brevetoxins, or Carenia brevis. These are the red tides that everybody talks about. Now, this one we actually do, the Louisiana Department of Health does sample for these routinely. And again, we're sampling out on top of our oyster reefs. These are strictly marine, but they still fall into this category of, you know, a dinoflagellate or, you know, cyanobacteria, all these items, these microorganisms that can produce toxins. And again, this is a neurotoxin, but again, it's mostly concentrated in shellfish, which is why they gave this one the neurotoxic shellfish poisoning. Now, another interesting thing about this one is that this one usually causes irritation from inhalation. You know, we're talking about wave action, lots of movement of the water, things crashing ashore, whitecaps. It disperses the water vapor in the air, and the toxin can actually get in the air. You breathe it in or on your skin, and it can cause problems. It causes, you know, irritation. There's been some studies in Florida where they have large amounts of red tides around the Tampa Bay area. It can travel as far as 4 miles inland, you know, depending on the type of wake and the type of disturbance on the water. The good thing is we don't have these here very often. And for one, we're monitoring like crazy, and we're trying to prevent anything from happening. But when they do occur, they don't last very long here. Our water is usually in constant movement, whereas on the coast of Florida, you get a lot of piling up of water. Again, it can bioaccumulate in contaminated shellfish. And you kind of see that pattern here. All these toxins have the potential to contaminate shellfish and organisms and fauna in the area. Just different symptoms that can go along with these. And, you know, you look at these symptoms, this looks like a WebMD kind of, you go and look for you type in and you got your symptoms, and you're like, that's it. I've got a headache. I've been poisoned by cyanotoxins. I had a, you know, shrimp po' boy the other day and I'm in trouble. No, that's not how it works. This would be something where you were specifically either in the water on a beach and you knew that you were potentially exposed to these types of items. And I would even, I'm not a medical doctor, but I would probably say you're going to need more than one of these symptoms to kind of go along with that exposure. And of course, like I said, you'd actually have to know you've been exposed. So these were the concentrations, and Brady had put them up there. These were from, like I said, the May 2019 EPA regulations that they had updated. Now, I want to go ahead and stress that, you know, we took these samples in 2019. We were sampling, you know, Brady and his teams were out there sampling like crazy, and we didn't get anywhere near these levels. And the algal counts were too numerous to count. So we're talking large mats of blooms. They're everywhere. They're right on top of the beaches that we have recreational activity at, and we still got nowhere near these toxic concentrations. We don't understand 100% why it didn't, or even if it did, why it would. It's not 100% understood yet. That's why we have testing like ourselves, Brady and his team, the Pontchartrain Conservancy, the Department of Health. We're trying to gather this data so that we can see these patterns before they happen and maybe, you know, put up advisories on when we should or shouldn't be doing something. So, we're talking 8 micrograms per liter. That is a tiny amount of toxin for the most part. And again, we didn't even approach it. Why? We're not 100% sure yet. And we're hoping that more data as we continue to collect, maybe we can see some patterns here. This bottom one here, and now this one I'm not going to try to, maybe a cylindrospermopsin, maybe, Brady? There we go. It's close enough. Okay, he's nodding in agreement. This one's not usually found too much in our area. This one's more of a tropical kind of toxin. Think more of like South America, a little closer to the equator. Some of the beaches in Australia have some of these toxins. As far as I know, we've never had any samples come back that have spiked that. Brady, I don't know if you would know that for sure. Any of our samples? No. So this is one we're not.
We haven't measured either.
Well, that's true. We didn't measure, so of course we didn't find any. That's very easy. But again, we're not looking because it's not very common here. We're going to look for that microcystins. That's the one that's that most common one. And of course, if you found concentrations that were high potentially in microcystins, let's say we got up there in maybe the 10 or 11 range, well, then we might say, well, there might be other toxins, or you would assume that there'd be other harmful things in the water at the same time. Okay, so this is kind of seems like a no-brainer, but we still have to tell people, when you see algal blooms, if you're in the lake or you're fishing or you're out in Lake Bourne or you're out, in the Mississippi Sound, don't go near them. Don't go drive up to say, hey, I'm going to go see if I can identify what this is. First of all, you probably don't know what you're looking at, but you're also getting close to things and potentially exposing yourself. And you might say, oh, well, I'm in a boat. I'm perfectly fine. Your boat's spraying that water up. It's aerosolizing it, and you're getting it all over your boat, which potentially you're going to have to put on your trailer. You might bring home. Your kids might play around it. We mentioned that these toxins can actually stick to surfaces and dry and persist. So avoid harmful algal blooms, all right? And we're not going to tell you, okay, well, that one's harmful and that one's not. Avoid algal blooms in general. Don't go near them. Don't swim in them. If you think you've come in exposure, or you got some on you in waterways, maybe you went there and you realized it was there after the fact, wash your body, wash your clothing as quickly as you can. Nice, clean, fresh water, soap. Same thing with your pets. Now, Brady got into this a minute ago, and about pets getting ill, and we find that pets, it's not that they have stronger effects to toxicity. It's because they lick their fur, or they may eat whatever's on their beach. And I don't know if everybody has a dog, but a cat would do the same thing. If it's going to find an animal or something, a piece of shrimp or a fish, it's going to lick it or bite it or something. It's going to go home and clean itself. They're just getting large concentrations of that toxin. So that's usually the consensus on why it affects pets quicker than it does humans. But I am no vet, just like I'm not a medical doctor. So if you have any of these symptoms, you seek medical attention. You have multiple symptoms, you're in a HAB area, you're consuming large amounts of maybe, or not even large amounts, so you're consuming raw oysters, and you were catching, some redfish in the area. There was a bloom, it had algae on it. Yeah, you might have some symptoms. Seek medical attention. If it's a pet or something like that, take them to the vet. What's a little disconcerting is when you go to the doctor, there is no test they can run for this as of right now. What they'll probably do is give you things to treat the symptoms, or maybe some chelating medications to maybe exit your system. But it's not something that they can run and swab you like we can do for COVID and say, oh, you're positive for neurotoxins. That's not quite how it works. So these are events that are non-harmful. So again, we get reports every year, like Brady started the conversation. He was saying, oh, we get phone calls, we get pictures of people driving over the Lake Pontchartrain, the causeway, and they're sticking their arm out the window while they're driving, taking a picture. We love those. And they'll say, oh, I saw algal blooms. This is terrible. It's really bad. It's not that it's great. We know that the lake might be thrown off a little bit, or the waterways in the area, the estuaries might be thrown off a little bit, but it doesn't always mean it's harmful. And when we say harmful, we mean harmful to humans, producing those toxins. Sometimes there are algae species that don't produce these toxins. But what can happen is if they produced in large enough numbers and they do run their life cycle and die, that they can deplete the oxygen in the waters. Now, everybody kind of thinks that when we talk about dead zones and oxygen depletion, we're thinking off the coast of the Gulf of Mexico, off the coast of Louisiana and the Gulf of Mexico, the giant dead zone. And they're not wrong. That's exactly what's causing those dead zones. Lots of different things, because there's a lot more interaction out there. But in the lake, that same mechanism can happen, especially when we release large amounts of nutrients into the lake. Does that mean it's harmful to humans? No. Does it mean it's harmful to the environment? Yes. It's kind of a splitting hairs here, but there are no toxins present as far as we know in these situations. When we're talking about affecting the environment, not only are we talking about, you know, the area around the lake, we're talking about the organisms in there. Fish and any other fauna that can actually leave the area do. They're smarter than we think. They go from an area that's low in oxygen. They're going to travel and get out of the way and move to where there's higher oxygen concentrations. The problem is our more sessile creatures, or creatures that can't move, like our shellfish, our oysters, crabs. Yes, they can move, just not very quickly. And zones of hypoxia can grow very quickly. We're talking, you know, a couple days, and they can come down pretty quickly. A crab can't walk that fast on the bottom of the Lake Pontchartrain. They're the ones that are going to be affected. And when we see that, that's when it starts to affect our recreational crabbers, the people that make their livelihood off of this. We don't have any shellfish really in the area. But again, these zones of hypoxia can leave the Lake Pontchartrain area and get into the estuaries of Lake Bourne and Mississippi Sound, where we do have more shellfish concentrations. So anytime you see these zones of hypoxia, we're not telling you, okay, well, we're not sure, or we see some algae, we're just going to tell you by sight. We're just going to tell you again, avoid the areas. Don't go driving your boat right through these areas. You are risking your health for something that we're not really going to be sure of just from a picture or some kind of identification. Does it help us when you call? Sure, but do not go investigate. You're putting yourself in harm's way. And the same thing, we get lots of phone calls. Look, I was fishing in the area, and I caught my limit, and is it okay to eat the fish? Or I've got a whole bunch of crabs out the lake. Are they okay? My first question is, when you were fishing, did you see any algal blooms? Oh, no, I didn't see any. Then you're probably fine. You know, we took samples in concentrated areas of algae, and we didn't hit toxin levels. So we are going to take the thinking of, if you didn't see the bloom, then most likely you're not going to have toxins in those areas. But I'm going to go ahead one step further and make everyone feel a little better about the fish and shellfish that they consume out of the lake or in these estuaries, is that most of the time when these toxins do accumulate, they accumulate in the organs of the fish and the shellfish. Now, so a fish, you know, it's going to be in their bladders, it's going to be in their kidneys, it's going to be in their gills, places like that. It's usually not in their muscle mass and muscle tissue. Those are usually more slow growing and don't take up toxins as quickly. So as long as you're eating, usually you're washing your fish really well and you're in fresh, clean water, and then you're just eating the muscle mass, you're fine. Now, it's a little more difficult with crabs and shellfish. You're eating slightly more of those areas. It's not always just muscle, and they do have a tendency to take up more of the toxins. But we've never had a reported case of a toxin exposure from eating fish or shellfish in the Lake Pontchartrain or estuary area, according to public health data. So that makes us feel good again. And we know we've had these blooms before. That makes us feel good again to say the seafood is safe. But again, use your best judgment. Do not consume or do not fish in those areas where the actual blooms are taking place. Move away from them, not only for the fish, but for your own safety. I don't have too much more. I just always stick my information up there. I know Brady had put a little bit. And of course, I want to do the same and thank the Lake Pontchartrain Conservancy and LSU. Dr. Sabell over there was a tremendous help to us when we were doing testing and as an advisor for our data. I'm going to stop sharing. Okay, did that work? Are we back?
Yep. And I guess we have time for a couple questions, depending upon any questions you want to ask.
I see Kelly clicking. He's going for it.
Can you hear me? Can you guys hear me?
I can hear Amy, but I don't hear Kelly.
Oh, hi. Okay, I have a couple of questions. And keep in mind,
Go ahead,
I'm an
Amy.
accountant, not a scientist. I'm an accountant, not a scientist. So, I mean, is the thought process that the algal blooms are a result of opening the spillway, or these like kind of one-off events, these outlier events, as opposed to like just Mother Nature every once in a while it's created? Is that a fair statement to make?
I would start off by saying, the nitrogen and phosphorus are the limiting reagents or the limiting materials as far as the growth of these species. The sun is an abundant supply. So they really have their uncontrolled or their really exponential growth when you oversupply nitrogen and phosphorus. So if that is the new norm, you have a tremendous amount of runoff from agricultural activities in the Mississippi watershed. If that continues and you have these spillway opening events, it's quite realistic to foresee or to predict that you're going to have continued algal bloom events. Now, whether or not they are harmful algal blooms or it's something that you cause environmental degradation by hypoxia, like Justin was just mentioning, that's a totally different conversation. So far, the data has not supported a HAB event, but we really need to collect more of that information to have confidence in that statement.
How do the blooms disband? Like, does over time they just kind of the water kind of washes it away, or the water changes whatever chemicals are in the water and just kind of goes away, or does it, like, how does it actually disappear?
Yeah, so that's a good point, and I guess we didn't discuss that, but there is a natural life cycle to these things, just like us. They die off and they sink down to the bottom of the lake, and maybe they are consumed by a crab or some other bottom feeder. Sometimes they're filtered out by oysters. I don't think they're metabolized by oysters, but usually what happens is that these materials break down by other bacteria in the environment, and that consumes the oxygen. And that's where the harm is in that cycle. When the oxygen is sufficiently depleted and it can't sustain fish or other aquatic life, that's when you have that fish kill.
Yeah, it was an interesting point about, because I have people ask me all the time, like when I tell them that I volunteer for the organization, they're like, can you eat the fish? Can you swim? Like, what's going on? I'm like, yes, you can eat I'm like, look at the data. Yes, you can, you can eat the fish, you can swim. But it's an interesting fact. I didn't know that the toxins don't really get into the muscular part of the fish that you eat, very easily. So that was interesting. The whole thing was interesting, but I'll take little tidbits and throw them out at dinner parties and stuff. But that was very interesting. I appreciate both your time and your expertise.
Sure.
Hey, can you all hear me now?
Yep.
Oh, great. Thank you both for the presentations. They're both very interesting, fabulous. I guess I have a couple questions, but my first question was at night in some of these algal blooms in the lake, do you see big drops in oxygen when the oxygen's high during the day? So I guess before you have a die-off and you have a low DO during the day, when the algae are respiring at night and maybe not photosynthesizing, is it dropping much? Has anyone measured that?
Well, I don't know if anybody is measuring that, but you would measure that if you actually did it. It's too much for us to try to collect that with field samplers right now, but I will say keep your eyes out on the lighthouse because what is coming is we are having a EPA sonde, or EPA has purchased a online analyzer, and it will take these readings for both DO and another it's a HAB protein called total, I think it's phycourethrin, PE is what it's abbreviated. But what we will do is we will be collecting this data 24/7 and reporting it to the website. I don't know exactly how that's going to look as far as the output on the website, but that's certainly one of the pieces of information we're going to love to get, is to look at possibly some of those changes, those diurnal changes, and over the day, changes in dissolved oxygen.
Cool. Thank you.
Thank you.
Can I ask another question?
Yeah, ask me right.
What about of the? Trying to remember the names. Remember, was Microcystis? Is that one of them?
Common, yeah.
Of these kind of various ones that you expect to be common or that you've seen are common in the lake, and then maybe subsequently washing down into Lake Borgne and Mississippi Sound. Do you have an idea of maybe relative risk to potential marine mammals that are maybe infrequent but coming in, like Atlantic bottlenose dolphin and manatees and things?
So it actually is very toxic, just like it is to us. Neurotoxins, especially, are just as toxic to the fauna in the area, and that includes even birds. If they swoop down and they're eating fish and they have toxins, to a small extent, it might bioaccumulate, but when they get to a certain level, it will prove toxic to them. I can only imagine. I don't know specifically about the mammals, the aquatic mammals in the area, but I would think that they would probably be a little more susceptible to those neurotoxins, just like we are, because I don't want to say there are aquatic mammals, but they're not fish. They have lung systems like we do for the most part, so they're going to get these irritants in their lungs, whereas a fish, it's not going to really be irritated, dermally like we are. It's going to go more to their brain and their kidneys and such. So I can only imagine that the mammals will be affected. One of the species they use, and in science we do some rough stuff and we do tests on organisms sometimes. One of the more common ways to figure out toxicity is to feed small samples to mice until we can figure out what that harmful level is. And the same thing, they'll use brine shrimp with microcystins sometimes to see what level it is toxic. So even to our white and brown shrimp that are out there in Lake Borgne and everything, toxins can definitely play a part. And we don't know 100% yet because the data, we're just starting to collect this great data. But does it actually hurt our harvest of those species? So that's a good question.
Yeah, and I was hoping, Justin, you would get to this, but there is some really fuzzy math involved in the determination of risk and safety. So we've talked about this 8 parts per billion number, and the way that number is derived, you have a study where you look at the mortality of either rabbits or mice. I think for this particular compound, they looked at a rabbit study. Then you have different safety factors and interspecies differences that you multiply by. And then, you come to what's in toxicity, it's called a reference dose. And you try to calculate how much it would take for a person to consume that reference dose. And you look at their body weight versus, the amount that they consume. So for this particular 8 part per billion range, it is calculated using a small child, and they've looked at this probability density of how likely they are to ingest water during a swimming activity. And they came up with this number that, based on all these studies, a child is likely to ingest 100 milliliters of water. So they compute that 8 parts per billion based on a small child that's like 4 or 5, I think was the key age, ingesting 100 milliliters of water, all these different, safety factors and margin of safety back calculated to a rabbit study. So there are inherent safety measures built into that 8 parts per billion too. But that is kind of the peer-reviewed benchmark that these different agencies will start with as far as establishing risk and safety measures, which is, it's always fuzzy math, but and it's always an interesting conversation to have in these COVID days now. But what is safe is kind of determined based on that fuzzy calculation.
That's great. Thanks.
Thank you. That was a great question.
If nobody else has questions, I have a question.
Go.
Okay, so I was wondering, you showed the relationship between the harmful algal blooms, and you said this wasn't one factor that could pinpoint when a bloom was going to happen. And I was curious about the turbidity and that relationship with turbidity, or like a combination of factors that might be able to say when a bloom was going to happen.
Yeah, so I think turbidity is going to be one of those measures that would be great in a really lovely area of the world, like Crystal River, Florida, or the Keys, or someplace where there's, usually a real low level of turbidity. But we can have really high levels of turbidity in the lake because that's a wind-driven event. So the wind comes up, the turbidity comes up because the wind, it's real shallow, and the wind tends to resuspend a lot of bottom sediments. So turbidity has not been a good predictor as far as predicting microcystin. This is probably going to be something kind of like COVID, where you have to look at specific genetic sequences and target those sequences with a fast kind of detection mechanism, the PCR test, and look to see if you have those pieces of genetic machinery present in your sample to warrant doing a further test. That PCR test, Justin, what does it take? 15 minutes to run a sample? It's a real short time frame. It'd be really easy to look at, the protein responsible for making this toxin, or, the chain of proteins responsible for producing these toxins, and see if they're in your water sample before going on and running this really expensive analysis. The commercial value, the last I heard, there's a laboratory in Florida. They were running these samples for $300 a sample. So if you're looking to collect something of statistical significance, you need a lot of samples, and that quickly blows your budget out of the water. So I think we need to develop some more rapid methods, or be a little bit smarter in decision making as far as when is a sample to be analyzed.
And to elaborate a little further, also, like Brady was saying, it's particular areas of the world. We're using this one study, like we're talking about toxicity, and everybody takes it and uses it as their own. And we're finding maybe this isn't the right thing to do. So what we've been trying to do is, and what Brady and the Lake Pontchartrain Conservancy has been doing in partnership with the Department of Health and DEQ, is let's look at our lake here. Let's look at our water system, because our turbidity is different from everybody else's. Our sunshine's different. Our temperature of the water's different. Our ecosystem is different from everybody else's for the most part. So let's base our science and let's base our data and gather all this on our area. And when we come up with these answers, I wouldn't necessarily say this is the way it's going to be for everybody, but we will know it's for us. And this is something that we are just beginning to do and pull these things. And we're just starting to get this data, but we just don't have that quite data set yet to bullseye these questions, or bullseye these answers, I should say.
And then I'm a professor at UNO, so I have a bunch of students, and I teach marine biology, marine ecology, and we're right on the lake. And so I would, I've tried to take them out to do some plankton tows and stuff, but I would love to be able to, maybe if you guys have the citizen science app you want them to, download and use, I'd love to be able to share that kind of stuff with my students and with the class to maybe bolster some data sets for you guys, or increase the education for my students. So if there's anything we could incorporate, every semester or every year I'm teaching this course, if we could sample for you, or go look for cyanobacteria, or do some water quality metrics in areas you don't normally get to go to with my student body. I'd love to be able to work with you guys on that, to increase the education of my students about Lake Pontchartrain that's right behind them. So if y'all are interested in that, or have any information that I could share with my students on it, please email me.
That's good to know, because we utilize, like I said, Dr. Sabel over at LSU, and we came about because she was researching some of the similar items, but to branch out, like you said, to use someone directly on the lake is always beneficial.
We're always happy to look at collaboration opportunities. So I think that'd be great. I'd like to try to connect with you sometime this week or next, and let's explore that space.
Okay, great.
There's a number with a 337 area code online. Do you have any questions?
No, I don't, but this is great. Thank y'all for sharing everything.
Absolutely. Thanks for joining. I hope I don't mispronounce this. Again, I'll blame my North Florida accent. Nichelle Taylor from Life City. Do you have any questions? Are you with us, Nichelle? All right, maybe not. Okay.
Brady, I would like to ask, are you going to make this presentation and our slides available for the public?
Yes. So I did try to record this. I don't know if it worked or not. This is my first time doing this. It does say recording in the top left-hand corner of my screen. But certainly I will we'll either try to find a way to share it, or I don't know how that looks, but I'll try to get something for you, Justin.
Well, for everyone.
All right. Anything else? Ridgely, questions?
No, I thought this was great. I learn a little bit more every time I listen to these bacteria names.
The bacteria names are very interesting, and I always get tongue-tied on them. But it is a challenge in this because we were specifically targeting microcystin in our analysis, and it is possible, although I don't think it's likely, but it is possible that you know, there can be other toxins produced by these critters that are out there, and we're not measuring or capturing that information. So areas for future research.
Yeah, there's a lot more to learn about it, definitely.
All right, well, it is 7:13, so it's well after the scheduled 7 o'clock time. I want to thank everyone for joining us. Thank you, Justin, for giving a presentation tonight, and thanks again. This was great.
Thank you for having me. Thanks, everyone.
I appreciate
All
it.
right, good night.
Good night.
Good night.